In this video, we are going to learn about positive displacement pumps. Let's begin with a brief outline. So, what is a pump? A pump is a mechanical device that moves a fluid. We can also say that a pump adds energy to a fluid. Pumps have operating limitations based on the height that they are pulling or pushing a fluid from or to. We call these distances head. There are three types of pump head: static, suction, and discharge. Let me draw a diagram so you can see. As you can see, static head is always discharge head minus suction head, as long as we follow a sign convention and use negative signs for elevations below the pump. So, let's discuss positive displacement pumps. As the name suggests, these pumps work by displacing fluid inside a chamber. There are two main types: reciprocating and rotary. Each of these two main types has multiple subcategories. Let's begin discussing the reciprocating pump. With a reciprocating pump, you can either use a piston-style pump or you can use a diaphragm pump. Piston pumps come in three flavors: rotational, radial, and plunger. The plunger style can either be single-acting or double-acting. A single-acting plunger pump is much like a bike pump. It only moves a fluid on one stroke. A double-acting pump moves fluid on both the downstroke and the upstroke, or the left stroke and the right stroke. One of the advantages to a double-acting pump is that it moves twice as much fluid per unit time as the single-acting pump. However, it is more complicated to assemble. With rotary pumps, we have single rotor and multi-rotor designs. The two single gear pumps are the internal gear pump and the vane pump. The multi-rotor pumps are the external gear pump, lobe pump, and screw pump. The screw pump can either be a twin screw or a triple screw pump. The advantage to the triple screw pump is that the torque applied by the driving screw acts symmetrically between the two driven screws. So with so many different types of pumps, how do you choose? It really comes down to what you are pumping and how big your pipe is. Reciprocating pumps do well over a wide pressure range, and they are self-priming, but they can only accommodate low flow rates and capacities, and they deliver a pulsating flow. Rotary pumps, on the other hand, deliver a more continuous flow, regardless of pressure, and they do not impart the full pump velocity on the liquid. They too are self-priming and work well over a wide range of viscosities and specific gravities. However, rotary pumps can only pump clean fluid. They can be easily damaged by contaminants, and they are quite noisy. Max and Brian are now going to show some positive displacement pumps in the real world.
All right, so here's an example of a positive displacement pump down here in Haverly. As an overview of the system, here's our pump. It has two sets of cylinders. It's attached to an air receiver. This is an air compressor system, and it's driven by an electric motor over here, which is also belt fed and connects to the pump. So following the trail of the working fluid, that being air, we're starting at our air filter. That's this component. We transfer into our first cylinder assembly, and through a series of valves, that air gets transferred to the other side of the system. As the piston reciprocates and creates the positive displacement effect, it causes a vacuum, drawing in more air, and the cycle continues. So through our valves, our air transfers into our second side to achieve the maximum possible compression for this air receiver. And it's the same principle on the other side as well. So we have the same valves. Notice that there are safety valves here, so these can come up to relieve pressure if necessary. And these transfer air into the receiver. That then exits through the valve in the bottom here to whatever it's mated to. And this system can run to fill this entire tank and creating just by that positive displacement effect.
This is a screw-type positive displacement pump. You can see here the path the fluid will travel through the pump, through the inlet and to the outlet. You can see these screws right here that the fluid is passing through. You have a cooling jacket around the screws to help them stay cool while pumping. You have a bearing plate here to hold these screws in place. You also have seals on both ends of the screws so that there will be no leakage of fluid. You also have this cooling channel which is for oil to flow through, which also helps with the cooling of the pump.